Good morning, everyone, and welcome to this lecture. This is lecture number 13. The topic is work by energy, and we are dealing with motion in horizontal circle. In the last class, we had seen what do you mean by motion in horizontal circle. If any motion is taking place in the horizontal plane in a circular path, we call it motion in horizontal circle, and we had seen an example of a body tied to a string and doing circular motion in a horizontal circle on the top of a table or ground. We had also seen that in case of any question that comes in circular motion, out of the three directions, we are supposed to make any two equations. What are the three directions? One is towards the center, one is along the tangent, and the third one, if required, is along the perpendicular direction. Sorry. In the question that we did, we had made all these three equations. As you can see, in the equation on towards the center, we got T is equal to mv square by r. There was no force in the tangential direction, so that equation was not required. The net force in the vertical direction has to be 0 from there. Sorry, we got the value of the normal reaction. Let us move ahead and see some more examples on this so that we are able to understand this. Let us move on to the next question. And this one is the next question. A block of mass m moves with a speed v against a smooth and a fixed vertical groove. So it's a it's a circular groove like this. And a body is moving in a circular path. Radius is r, and as you can see, it is moving with a velocity v in that circular groove. You have to find out two things: normal reaction of the floor. This is the floor, there is a groove, and the body is moving in a groove. You have to find the normal reaction of the floor on the block. You have to find the normal reaction of the vertical wall on the block. You have 2 minutes to know the process, make the equations, and get your answers. I will give you 2 minutes to do this. So how are we supposed to do this? It's the same question as what we did in the previous class. I don't think that you remember it. That's a very bad sign. Anyways, I will do it for you. If I draw the free body diagram, the weight mg of this body is down. The normal reaction from the floor is upwards, and then there is normal reaction from the wall. I call it m2, and this normal reaction from the wall is providing it with the centripetal force. I make the first equation towards center. I make the first equation towards the center. The net force towards the center is N2, and that must be equal to the centripetal force mv square by r. I make the second equation, which is towards the tangent, towards the tangential direction. In the tangential direction, there is no friction, there is nothing. Therefore, the force is 0, there is no force. I make the third equation in perpendicular direction. Perpendicular direction is the vertical direction. the net force must be 0. Net force must be 0 means N1 is equal to mg. And these are the answers that we were looking at. It's very sad that you cannot do it. Very, very sad. Very, very sad. But this is exact copy of the question that we did in yesterday's class. I don't think anyone remembers it. The only difference is here there was tension which was providing it with the centripetal force. In this question, the same work has been done by the normal reaction. I'm very disappointed with your returns for this question. It means that no one studied in the hostels. Not a good sign. Anyways, I have to let my disappointment go, and I'll give you 2 minutes to note down the problem. Please note it down, and I hope that you remember it. Well, then we move on to the next question. This is the next question, and I hope that you can do better with this question. A block of mass m is kept on the edge of a horizontal turntable. What is a turntable? A turntable is a table that can turn. This turntable is rotating with a constant angular velocity omega, but it is turning together with the block. So with respect to the table, the block is stationary. The turntable is rotating with the block. The coefficient of friction is mu. Well done. The coefficient of friction is mu. Find the frictional force between the block and the table. You have to find out the frictional force between the block and the table. And again, I'll give you 2 minutes. In every question, you have to do the same thing. You have to make 3 equations. Once you make those 3 equations, you should be there with your answer. I hope that you can do justice to this question. I have full faith. Let's give you a couple of minutes and let me know once you are done. If you're not able to do it, let me know. So how are we supposed to do this? If I have this as a table, this is my circular table, and this circular table has a radius r. The circular table has a radius r. The center is O, and let us suppose that the circular table is rotating with an angular velocity omega. Anyone draw the diagram? Anyone among these people? Did we draw the diagram? Okay, good. Then there is a block which is kept here at the edge of the table, and it is rotating together with the table. Do we understand this? Yes or no? Now, if it is rotating with the table, something must provide it with the centripetal force. What is providing this block with the centripetal force? Which force is providing this block the centripetal acceleration? Which force is acting as the centripetal force? Anyone, any idea? No one, no idea? It's not there in the book, so you don't have to look at the pages of the book. You will not find anything there. Which force is providing it with the centripetal force? In the first case, the first question that we did, there was tension in the string. In the second case that we did, the block was moving on a circular path like this. The normal reaction from the circular groove was giving it the centripetal force. In this case, what is giving it the centripetal force? Yes?
Friction.
Friction. Well done. What type of friction is acting between the block and the table? What type of friction is acting between the block and the table?
Static friction.
Well done. That is the answer. Good. So you know everything. Static friction is acting between the block and the table, Fs. As soon as you get the friction as static, there is one thing that is sure. You know the direction, but you don't know the what? About static friction. What do we know and what do we don't know? Yes, my dear friends. We have forgotten.
Magnitude.
We do not know the magnitude. Okay, great. Okay, we don't know the magnitude, but let us make the equations. The first equation is towards the center. What is that equation? Who will tell me? Who will tell me what is the equation? Towards the center. No one knows it. Well, the free body diagram is here. Fs must provide it with the centripetal force. And so, my dear, the answer is here. The value of static friction is m omega square r. That is all that was needed to solve this question. Mu is not required at all. I don't know why some of you said it is mu times this. You just multiplied mu just because mu is given to you. That means you have to multiply it somewhere. That does not make any sense at all. Anyways, let me just proceed and write the second equation. In which direction do I write the second equation? Can anyone tell me in which direction do I write the second equation?
Towards the tangent.
Towards the tangent. Do you see any force in the tangential direction? Do we see any force in the tangential direction? Along the tangential direction, do we see any force? There is no force. So there is no equation along the tangential direction. But is there, what is the third direction in which we can make the equation? What is the third direction in which we can
Perpendicular
make the
vertical
equation? Yes?
perpendicular.
Perpendicular direction we can make the equation. Can anyone tell me what are the forces acting in the perpendicular direction? Remember, whatever happens in the perpendicular direction, the net force in the perpendicular direction has to be zero because it cannot, the, there is no motion in the perpendicular direction. Force has to be, net force has to be zero. Can anyone tell me what are the forces in the perpendicular direction? Remember, this motion is happening on the horizontal table. Yes, anyone?
Sir,
What?
your screen is not visible.
Answer my question, what I'm asking. Don't worry about what is happening or what is not happening. Is there any force in the perpendicular direction? What are the force in the perpendicular directions?
Normal, sir.
Only normal, nothing else? Okay, let's not waste much time here. I don't think you understand the concept. And we are doing the same thing in the third case also. Don't know you have understood this. Normal reaction will be equal to mg. I cannot draw it here in this diagram because it is going like this. If I just draw a different view of this body of mass m, it is kept on the floor. There would be normal reaction coming from ground and there would be weight mg which is acting downwards So normal reaction is equal to mg. That is not required, that was not asked in the question. But there could be one more question that could be asked. If I keep on increasing the angular velocity of this table, will the block always keep on moving with the table, or at some time something else will happen? And this has got nothing to do with physics. I keep on increasing the angular velocity of the table. Will the block always remain turning with the table, or something else will happen?
It may fall, sir.
It will slip on the table. So if I keep on rotating it, at some time it will just slip and just move away from the table. What is the maximum omega possible for the block to remain moving with the table? That is the next question that is asked. Find omega max for which block rotates with the table. What is the maximum angular velocity for which the block rotates with the table? And I will not give you any time to do this because I know you may not be able to do this. What is the maximum angular velocity for which the block rotates with the table? Now, how do I do this? I know the value of Fs is this. I know the value of normal reaction is this. Now, the block is rotating with the table just because of the frictional force, which is static in nature. When you increase the value of omega, frictional force can increase. If you increase the value of omega, frictional force will keep on increasing. But frictional force cannot go beyond a particular limit. Static friction cannot go beyond a particular limit. How much is that limit? What is that known as? Please tell me, do you know it?
Limiting friction.
Limiting friction. So the value of the static friction has to be less than or equal to limiting friction, and this limiting friction is always equal to mu multiplied by n, where mu is the coefficient of friction. What is the value of static friction that we are getting? The value of static friction is m omega square into r. That is the static friction that we require. This will be always less than or equal to mu into n. And how much is n? N is already known as m into g. I've just put the value of static friction. I've just put the value of static friction from this equation, and I've just put the value of n from this equation. So m omega square into r will be less than or equal to mg, m and m cut. So omega square will be less than or equal to mu g by r. So it will always be less than this value. In the maximum condition, it will be equal to that value. So the value of maximum angular velocity that is possible will be equal to mu g by r, and this is where mu is required, not just everywhere. Mu only comes in case of static friction. Mu only comes when you have to find out the value of limiting friction. That is the only case where mu comes, my dear friends. Else, mu does not come. This is how you need to solve it. We have done 3 questions exactly similar, exactly similar, exactly similar, exactly similar, exactly similar, exactly similar. I'll give you 5 minutes now. Take a deep breath Deep breath. There's no point of me just writing the question and giving you time and you're not able to do this. That is a waste of everyone's time. What I'm going to do, I'm going to give you 5 minutes. Take a deep breath and look at all the 3 questions that we have solved. Aram, quietly, patiently. Then only I'll give you the next question to solve, and then I'll only give you 2 minutes to solve the question. So your 2 minutes, 3 minutes to look at all the 3 questions begins now. Look at all the questions, they are exactly similar, and this is how you have to solve all the other questions as well. 3 minutes begins now. Note it down. Then comes the next question, which I hope that you can do. And this is known as the question of the death well. I don't know how many of you have seen this death well. Anyone has any idea what is a death well? Death well. We call this question as the question of the death well. What is this question of the death well? There was a point in time where there used to be fairs, melas in your town. And in those melas, people used to come and, they used to put stalls, big swings, chulas. And then there used to be a motorcyclist who used to move in a dung circus. We can call it a circus as well. Motorcycle moves in a that well, and he keeps on moving the motorcycle fast. This is another version of the motorcycle man. This is known as a death well. So what is in a death well? In a death well, what happens? You have a cylindrical shape box, and this a boy or a man is like he's not glued to the wall. He just is sticking. He just is in contact with the vertical wall of the cylinder, and then cylinder starts to rotate. A boy stands on a horizontal platform inside a cylindrical container of radius r while resting his back on the inner surface. So he will rest his back on the inner surface, and he's not tied to the surface. He just sticks. He is just putting his back against the surface, and the cylinder starts to rotate. The cylinder can be rotated. So the cylinder is going to rotate about this axis. It is going to rotate like this. The coefficient of static friction between the inner surface of the container and the boy is μs. Now the angular speed of this cylinder will be increased. We will keep on increasing it. What will happen when we increase it? Is increase. Find the minimum angular speed at which, if the platform below his feet is removed, the boy should not fall. Oops. Then all of a sudden, the platform or the floor on which he is standing, it will fall. Bloop. But the boy will not fall. Eh? Why will the boy not fall? This is known as the death well. What should be the angular velocity? Minimum angular velocity for which the boy does not fall, or the man, even though the floor on which he is standing falls, comes out, the man does not fall. Why does the man not fall? Well, that is the question. He hardly knows anything about physics. He has not studied Newton's law, does not know static friction and all. We know it. Can we tell him why he's not falling? We have 2 minutes to do this. The death well problem. Okay, so this is how it has to be done. This is the cylinder, and the small thing that I've drawn is the man. And I'm not going to draw the free body diagram. The weight is mg. Now I've assumed that there is no platform. There is no platform, there is no floor here. Now he is rotating in a circle, so something must provide it with the centripetal force. Who is going to provide this man with the centripetal force? He's moving in a circle, his back is on the vertical wall. Who is providing him with the centripetal force?
Normal, sir.
From where? From ground or from the vertical wall?
On the vertical wall.
From the vertical wall. Normal reaction must be there from the vertical wall. Now the platform, let us say, has gone down. Now if the platform has gone down, he will fall, but something is there which is stopping him from falling. What is that thing which is stopping him from falling? If the floor goes away, he has to fall, but obviously he is not falling. Something is stopping him from falling. What is that thing that is stopping him from falling?
Friction.
Yes, remember it is static friction that is stopping him from falling. If we understand this, my dear friends, we are done. The first equation. In which direction will I make the first equation?
Towards center.
Towards the center. What is the equation?
Is equal to mv square by r.
Well done. N is equal to m. V is not given. It is m omega square into r. Okay. What is the second equation that we are going to make? In which direction? It will be in the tangential direction along the cylinder like this. Is there any force acting in that direction? We will see there is no force. We see that there is no force. So there is no point of making that equation. What is the third equation that we should make?
Perpendicular.
This is again moving in a horizontal circle. So I have to make equation in the perpendicular direction. In the perpendicular direction, F net has to be 0. What are the forces? They must equate. Can you tell me the equation in the perpendicular direction? Anyone?
Fs is equals to mg.
Fs is equal to mg. Now we are talking. Now let us move fast. So he is basically dependent on the static friction, but we always know that the static friction is always less than or equal to limiting friction, and that limiting friction is always equal to mu into n. I now just put the values. Static friction, I will put the value from here. So what is the value? Static friction is trying to balance the weight mg, should be less than or equal to mu. How much is n? I will put the value of n from here. What is the value of n?
M omega square r.
M omega square r. Remember in the previous case, I was getting the maximum value of mu or of omega. Here I am going, because omega is coming on the other side. Here I will get the minimum value of omega. This cuts, this cuts. So omega square should be greater than or equal to g divided by mu r. It should be greater than this value. The minimum value therefore would be omega minimum value would be equal to root over g by mu r. Do we understand this, or this has gone above our head saying bye bye sir, bye bye sir, and bye bye sir? Do we understand this, how I've done this? Anyone got this answer on their own? Well, then that is the class for today. In next class, we will be winding up this horizontal circular motion. I hope once you get back home, you do all these problems with your own hands without looking at the solution. If you can do this, that would be a good exercise. I will wind off this class here. I'll see you in the next class. In the next class, we'll wind off this horizontal circular motion. I hope you have understood what we have discussed in today's class. Three equation, center, tangential, perpendicular. That's all that we need to do. And with the free body diagram. I'll see you tomorrow. God bless all of you. Bye-bye.
Thank you, sir.